Thank you and welcome to our inaugural kickoff seminar series for spring of 2022 for the UNIFI Consortium. My name is Ben Kroposki and I'm the organizational director of the consortia. So today I'll be giving a presentation about the consortia, a bit of an overview of what's going on, and then we'll save some time for questions at the end. So hang on. Okay. So thank you. Again, my name is Ben Kroposki. I'm the organizational director for the UNIFI Consortium, and we'll be talking about the UNIFI Consortia, giving you an overview of what's going on now that we've officially started this particular program. Again, the UNIFI Consortia stands for Universal Interoperability for Grid Forming Inverters. So as we start off, I did want to make sure people pronounce our name correctly. It is UNIFI, and you'll understand the reason why it's called UNIFI here shortly. But one of the things that we are looking at doing is have a vision around future power systems that integrate any mix of machines and inverter-based resources at any scale, and these power systems are affordable, secure, reliable, clean, and resilient. When we think about what we're trying to do in the electric power system now, we're undergoing a significant transformation. And just as an example of that, you can see a graph over to the right of this slide. What that's showing is system size in gigawatts, all the way from very small island power grids up to large power grids over 100 gigawatts to 1,000 gigawatts, which is the installed capacity of the continental United States. And we're seeing ever increasing amounts of wind and solar technologies being integrated into this into the power systems. From this graph, you can see a variety of different numbers and levels. The square boxes represent instantaneous power, which is at any particular point in time, the amount of wind and solar or inverter-based resources that we're able to run and operate on these grids. And the circles represent annual energy. And one of the things that we're really trying to do is make sure that we can get these annual energy numbers up for large integrated grids to the same level that we're seeing on small island power systems. So the purpose of the UNIFI Consortium really is to address the fundamental challenges to the seamless integration of grid forming technologies into the power system of the future. And again, the right-hand graph there, that red line is representing kind of the curve that we see happening right now in terms of the amount of wind and solar that we can integrate in large power grids. What we're trying to do through this UNIFI Consortium is conduct the necessary research and development, demonstrate concepts at scale, develop best practices and standards, and train the next generation of workforce to drive these power levels on large power grids from relatively low numbers to much higher instantaneous levels. And so if we can get these numbers here on the right-hand side of the graph much more closer to 100%, say 90 to 100%, what that will do is pull up our annual energy levels, or the amount that we can run on an annual basis, up over 50%. And this is necessary to achieve the long-term clean energy goals of a lot of countries around the world. And we think that this idea of being able to pull these instantaneous values up closer to 100% and operate grids with high levels of inverter-based resources like wind, solar, and batteries is really the most critical problem to solve when we're looking at how to create these sustainable energy systems. So what is UNIFI? UNIFI is a consortium. It's a forum to address these fundamental challenges with seamlessly integrating grid forming technologies into power systems of the future. It's really designed to bring together and unify the integration and operation of inverter-based resources and synchronous machines. And we have three major focuses, which we call thrusts: research and development, demonstration and commercialization, and outreach and training. Now, the Department of Energy, and specifically the Solar Energy Technology Office inside the Energy Efficiency and Renewable Energy Office, is funding us for a 5-year effort to bring this organization to fruition, with the idea that after 5 years, we would continue through memberships in the actual organization itself and be sustainably funded. So where are we and how did we get here? So about a year ago, the DOE announced the funding opportunity for Grid Forming Inverter Consortium. In April of last year, we built the UNIFI team and submitted a proposal to DOE. Over the summer of last year, DOE announced the award and we started negotiations. And then late last year in November, we completed the development of our technical work plan for the 5-year DOE funded portion of the project. And then in December, we've completed the development of individual statements of work for all of the DOE funds and cost share. So January 2022, UNIFI has actually started and we've kicked off and started running. So here is a picture of the organizational structure for the consortia itself. So at the top, the National Renewable Energy Laboratory, University of Washington, and EPRI are co-leading this entire organization. We have an internal leadership team made up of universities, industrial players, and utility or system operators. And then you can see those 3 main thrusts. Now inside each of these 3 thrusts, you'll see 4 bulleted areas, and we'll be going through these in much more detail in future slides. But these are the areas of work that will be happening throughout the lifetime of the project. And as you can see here, big focus around research and development, the commercialization and demonstration, and outreach and training. Now, in addition to this, we're set up in such a way that we have a large external scientific advisory board that we'll be meeting with on a regular basis every 6 months to review overall work that's going on the project itself. And then annually, we'll have a DOE review board that's taking a look at how we're managing the overall consortium and understanding the overall sustainability of the organization itself. You can see a lot of the logos listed on here, and we'll talk about the partners that are specifically on the project. Now, those areas and area leads, you can see they're listed here. And the people that are specifically responsible for each of these specific areas. I just highlighted their names to make sure that people, in case they were interested in specific areas, would know who to contact. But in general, these are the people that are organizing and have put together the work plans in these various areas. The research and development, demonstration and commercialization, and outreach and training. So the project team, now the project team currently consists of everybody who is receiving DOE or federal funding or providing cost share or both. And you can see from here we have a variety of national laboratories and research institutes, so NREL, EPRI, Sandia National Labs, PNNL, and Lawrence Berkeley National Lab, a variety of universities, including the University of Washington, Minnesota, NC State, University of Wisconsin, University of Illinois, University of California, Georgia Tech, ASU, University of Puerto Rico, Temple University, University of Alaska Fairbanks, and Virginia Tech. And then you can see we have a large number of industry players in this. So both from the vendor side, either developing grid forming technologies or some of the advancements in modeling and simulation and hardware in the loop technologies, as well as utilities and system operators. And these people are providing to give their expertise on how to best integrate these type of technologies into electric power grids. We also have a set of additional partners. In this particular case, when we're talking additional partners, these are people that have confirmed their participation through letters of support and potentially are additional members of the consortium itself. So we have a variety of additional utilities, a variety of additional vendors that we've been discussing with, software vendors and system operator. And then last but not least, we're also working collaboratively with a variety of consortia in this space. So there are other entities dealing with power systems or power electronics, and how those systems integrate together. So we're trying to make sure that we can coordinate with the best practices of various other consortia that are happening in this area. So now let's dive into the details and talk about specific high-level goals of the UNIFI Consortia. At the end of the day, what we're trying to do is listed up here in this first bullet. We're trying to curate vendor and technology agnostic, what we're just kind of terming unified specifications around interoperability guidelines at a system level and functional requirements at the technology or inverter-based level. And this would really help standardize performance, benchmark capabilities, and make sure that if you can meet these high-level specifications, that you can ensure interoperability between devices across the entire power system. We'll be diving into this a little bit more in some future slides here. So the entire consortium itself is really designed to create this ecosystem to foster work in R&D, demonstration, commercialization, outreach, and training to drive the next generation of grid forming technologies. We have goals to really try to establish the U.S. as a leader in this space around photovoltaics, wind, storage, where these grid forming technologies are just starting to be used at a significant level. But we also want to cultivate an inclusive culture in this area, to making sure that we can basically bring together people across the industry, academia, research laboratories, and make sure they can work collaboratively in a space. And again, one of the things that we're driving hard here to do is kind of create this collaboration between the inverter manufacturers on one side of the system and the system operators and utilities on the other side, and bridge the gaps between power system and power electronic industries. So let's talk a bit about the architecture of what we see happening in the grid forming space. If you take a look at the diagram over to the right-hand side here, you can see a lot of things, but we'll start to point out specifically the grid forming inverter technologies. So in grid forming inverter technologies, right, that could be an individual singular technology. It could be plants where we start to aggregate many types of inverters, typically co-located, or it could be aggregations of grid forming technologies. This little blue diagram in here is our representation of a grid forming inverter. And if we look inside each of these boxes, what you'll see is that we are identifying what are the unit level functionality that can be included in here. So obviously, you're going to have something that's doing power conversion, and typically the vendors of these products are keeping a lot of those controls proprietary. But what we're really focused on is how do we start to develop interoperable grid forming controls, and then the input and output signals that will correctly take information from a system operator to properly ensure overarching stability and reliable operation of these techniques. So what we're really focused on inside this area is developing the specifications for making all of this happen. You can have a variety of, once you set up these types of signals, you can have distributed optimization and control algorithms across the entire balancing area that may be required for proper system operation. And we're going to see advances both on the unit level and at the system level to make this happen across large scale power grids. Right, so we know how to do this if it's a singular inverter on a very small system. But what we're really focused on in this consortium is how do we envision this entire system operating for all scales of power grids. So now I'm going to dive a little bit more into the details of each of those various thrusts. First, we'll start off with the research and development thrust. Very quickly, we're going to hit modeling and simulation, controls, and integration and validation in this section here. So if we take a look at the modeling and simulation area, you can see that current modeling and simulation, ranges across a large number of time scales, all the way from very fast switch level electromagnetic transient modeling to how we aggregate these together and look at larger scale dynamics, all the way up to things like production cost modeling. But the challenge here is, how do we actually make sure that grid forming technologies are properly integrated into these environments? So that's where we're looking at how do we develop interoperable standards for grid forming models that can be directly used by various software vendors in this space. We also want to make sure that we're developing hardware in the loop compatible models so that we can start to tie together how you're doing the modeling and simulation with real world hardware applications. And then another thing that we're looking at doing is tying in the variety of protocols in this area so that we can create software platforms that would provide sort of workspaces for us to test out these models, to evaluate them and validate and verify them with some of the experimentation that goes on. So we currently have partnerships with all the major vendors in the power system simulation software area, and can range all the way from EMT modeling up to real-time simulations and the regular positive sequence simulations. We're also very focused on developing controls in this consortium. So understanding and getting a better look at both the individual interoperability controls that are happening inside the inverters themselves, which are typically what we would call the primary control algorithms that are happening within the inverters, as well as the scalable secondary controls. So how do you accept signals to either regulate voltage or frequency or power from a system operator? And how do you make connections between these areas? So we'll be, as part of this project, doing R&D in the controls area and looking at how to develop these types of controls. But at the end of the day, what we want to focus on is how we tie these two together in sort of a vendor agnostic fashion to ensure stable operational control across these systems. In the integration and validation area, we're working on how to test and evaluate, validate all of these specifications that are being developed. And that could be at the control layer or the communications layer, or even when we start to emulate all of these devices together. What we want to, again, want to make sure that we're able to do is allow vendors to build products. And then as long as they're following a certain set of rules that enable the secondary and primary control, that they can interact with other vendors that are following the same sets of rules to provide interoperability across these types of systems. Inside the team right now, we have a number of testing facilities, and we're focused on how to make best use of those, either from the real hardware evaluations from kilowatts to megawatt scale, as well as how complex we can make these systems. An example of that is our big 1 megawatt experiment that we have planned for the 3rd year of the project. And really what we're trying to do here is create a hardware test bed that would allow all vendors that are following the UNIFI specifications to come in and plug in their devices with a bunch of other vendors, and without knowing the actual control algorithms inside there, they should be able to operate properly given a bunch of different conditions. So we're looking at initially how to set this up at the NREL Energy Systems Integration Facility, where we can evaluate things up to the megawatt scale. We'll be looking at a variety of different generation, single, 3-phase, various loads, looking at multiple source side resources, and then looking at various levels of grid forming capability. So we want to be able to make sure that you work with almost any level of grid forming capability, grid following capability, and synchronous machines inside of this area. Okay, moving on to our demonstration and commercialization thrust. You can see 4 main areas in here. We have a 20 megawatt demonstration. We have also IT management and domestic products, and then also standards in this area. So let's just talk about what our plans are in the 20 megawatt demonstration. So moving on from that 1 megawatt experiment where we can accurately control all the different parameters, We're looking at sites right now where we can deploy over 20 megawatts either as a single large-scale plant. So an example of that could be a large-scale PV plant with multiple inverter vendors in there, or it could be a highly distributed set where we have lots of distributed resources across a spatial area. And the nice part about this is we get a little bit more diversity in actual sizes of equipment. But what we're trying to do right now is identify a variety of different options for this demonstration. What we want to demonstrate is that we can provide a full set of these services from the grid forming inverters and validate the interoperability guidelines and functional requirements. So I'll just put this out there in case people know about potential sites, and we're still looking and evaluating a variety of these. But we're looking for sites that contain a mix of resources, a mix of grid forming and grid following and machines over a wide variety of power ranges, and also multiple source size energy sources. What we would like to do at the end of the day is evaluate these, what we call UNIFI specifications for interoperability and functional requirements, looking at primary and secondary control, how you do voltage and frequency control, power sharing among the units, black start capability, and the ability to run 100% of inverter-based resources. So feel free to follow back up with me or any of the UNIFI members if you know of particular sites that would be good for this. We've done prior work in this area where we've tapped into the ability of large-scale projects and done demonstrations. So an example of this was a few years back. We worked with First Solar and the California System Operator on evaluating the potential of very large-scale PV plants, in this case, to provide a variety of grid services. What we show in the graph over here on the right is the ability of those large-scale plants to provide up and down regulation services following an automatic generator control off of this 300 megawatt plant. But again, this is a single plant, not really demonstrating grid forming capabilities, but how we're able to go in and evaluate these types of systems. Okay, so a couple other things around the commercialization and demonstration area is IP management and product development. And what we're planning to do is work with our members to determine what we are calling a core stack of IP. This would enable the grid forming technologies to meet the interoperability guidelines and functional requirements. And it really revolves around this piece here where we're able to make sure that any of the, as long as you're following these requirements, you can ensure interoperability between multiple different vendors. And that way people can still keep all of their proprietary information about how they're doing the operation inside their boxes or inside their inverters, if you will. But when they interconnect at a system level, they're all working together as a cohesive unit. And moving beyond just that is really the world of standards. So currently, if you take a look at standards in this area, there's two big ones out there, IEEE 1547, which handles distribution interconnected distributed resources, and the new P2800, which is looking at transmission connected inverter-based resources. This particular consortium will be doing a gap analysis on these existing standards and understanding how to develop this set of minimal capabilities to eventually meet these requirements. So the UNIFI Consortium will really focus on developing these specifications and then work closely with the standard development organizations to bring in the grid forming inverter expertise into future updates of these standards. So these standards are always continuously being updated. In fact, P2800 hasn't actually been officially turned into a standard yet. It's very, very close. It's going through its final balloting stages right now. But there's still opportunities to improve this when it comes to grid forming technologies. Similarly, IEEE 1547 was first published in 2003, went through a significant update in 2018, but again, still has not got a big focus around the grid forming capabilities of distributed resources. But the UNIFI Consortium itself will be working on this. Okay, then migrating to outreach and training. This particular thrust really is focused around education, workforce development, communication, and events. In fact, probably since we've started kicking off here, we're going to be tying to other big events in this general area. So most people are probably familiar with the IEEE Power and Energy Society General Meeting that'll be held in July of 2022 in Denver, Colorado this year. And our first general meeting of the UNIFI Consortium will also be tied to that particular meeting. But as ways to create information and make sure that we're getting the word out about these type of developments in grid forming technologies, we want to tie to a lot of these large scale events. So in addition to that, we're looking at how do we do trainings, especially when it comes to grid forming inverter technology. How do we make sure that the people that are doing modeling, simulation, design of power systems know the latest on grid forming technologies? We're developing both educational programs and workforce development in that area. We may be looking at how do we host things like interoperability events where people can bring in their inverters and evaluate how they work together. Of course, we'd love to get back to in-person workshops that highlight in this space, and we want to leverage a lot of the institutional partnerships that we've developed among the current members of the organization to, again, reach out around the world in some cases to making sure we're getting the word out on grid forming technologies. Another big piece of outreach is what you're listening to now, which is our seminar series. So mark your calendars for the next 5 years. We plan on hosting roughly about 15 seminars every spring and fall. They will be at this time, Mondays from 4 to 5 p.m. Eastern, so that you can go ahead and fill up your calendar for the next 5 years. We had a great session of seminars in the fall, and then I'm kicking off right now another great session of speakers that will be happening this spring. So moving forward, where are we heading from here on out? So first off, I'll just, you've heard me mention this many times around interoperability guidelines and functional requirements. All of that is going to be captured in the what we call the grid forming architecture and metrics manual that we're developing. And so the UNIFI Consortium members will be developing, reviewing, updating these documents on a regular basis. These will be critical for ensuring, the proper operation of grid forming technologies in power systems. And it's not going to be a static document. We're going to be updating this basically on 6-month intervals based on the modeling and simulation that gets done, or the controls development, or the testing, evaluation, and demonstration that goes on in the project. We also want to focus on making sure that we're meeting the metrics around scalability, reliability, stability for how these technologies can be deployed at significant scale in the power grid itself. And then finally, making sure that we're pushing this information as the standard development organizations progress on updates to those standards. A lot of the members are heavily involved with those working groups, and we see that as a pathway to eventually getting all of this work standardized. So one last slide here on the specifications around interoperability and functional requirements and what that really includes. So first off, we are talking, when we talk interoperability guidelines, we're mostly focused on system level guidelines across the electric power grid that would promote coordination and operation of many grid forming technologies from multiple vendors while ensuring stability and reliability. And again, this would focus around things like scalable secondary control methods. How do you push out the signals from a system level perspective that manage voltage and frequency on the grid? Currently, right now, we do, for large scale generators, we push out what's called automatic generator control signals. But if we think into the future, how do we get those type of signals down to lots of distributed inverter-based technologies? Ensure system level stability, make sure that you're properly regulating voltage and frequency. And then this is where things like black start capability, as soon as you start thinking about the grid forming products, they now have the ability to form grids. So those can then be used for black starting the grid and embedded in system restoration processes and procedures. Of course, on top of all of that, you need to ensure cyber secure communications is going out to these devices. And then on the individual inverter level, so this is where the functional requirements that make sure that they can satisfy all of these guidelines above, where we're tying in things like the real-time control with any type of dynamic protection. You also have the built-in autonomous primary control that's happening inside your inverters themselves. How do you make sure that you're passing the right signals to these devices and getting those from the system operator? How do you ensure aggregations of these are stable? And how do you ensure power quality and protection requirements? So again, this is kind of a first peek of where we're heading with these UNIFI specifications, but the UNIFI members will be developing these and then evaluating those across the timeline. So a couple questions. I guess preempted the questions here, but just wanted to put these out here, like, how can I get involved with UNIFI? So UNIFI is in the process right now of setting up a membership structure over the next few months that would allow organizations that were not part of that original project plan to join. So you'll be finding out about this soon. Some of the benefits of membership are things like access to the working groups. So inside each of those areas, we have working groups that are working on different aspects of this entire puzzle, but this can get you plugged into those working groups. Participate in the development of these grid forming inverter interoperability specifications, access to the experts that are embedded on this particular project, and access to the educational and workforce development material. And then where can you find out more information? So we are putting together a website right now. It should roll out later this spring. The website will provide more information on how to access memberships, as well as how to access the specifications and materials, as well as we'll have part of that site dedicated to public information as it's made available. Finally, we'll also be sending out information on LinkedIn. Check for the UNIFI Consortia group in the LinkedIn area. Okay, with that, I'll say thank you very much, and we will take questions. So thank you. Okay, so now we are going to, you can go ahead and stop recording.